Hello guys and welcome to a new lesson of physics. Today we are going to study a new topic which is called electric current and electrostatic charges. Let's first begin. What is the meaning of electrostatic charges? Scan the QR code and watch the video, then return back to me. Electrostatic charges are charges that are collected in one place without moving. So we are going to say that this object which is collecting charges is charged. Let's look at this balloon. If I'm going to make a friction with the shirt, so it's going to collect the negative charge from the shirt as a result of friction. So now this balloon is charged. If I'm going to move this balloon towards the shirt, this attraction force between them, as the balloon is negative and the shirt is positive. But with moving the balloon to the wall, the negative charge at the wall will be repelled and the balloon attracted to the positive charge at the wall itself. But the attraction force here is very weak because the wall is neutrally charged, not carrying any charge on it. So, as we said, the electrostatic charges are charges that are collected in one place as a result of friction. Also, while you are moving, your shoes collect negative charge from the ground, from the friction with ground. As a result of it, some sparks happen when you touch any metal. That's the reason some of you guys are able to transfer electric current when they touch anybody. So we are able to define the electrostatic charge is the electric charge that can be collected and held on one place as a result of friction, and the electrostatic charges are collected result of friction, as we said. Types of electric charge. We have two types of electric charge, guys. One of them is negative and the other one is positive. The negative one is the electron itself. So the electron charge is negative, while the positive one is called hole, which is the place of removed electron. Any object we have in this world, guys, is neutral. But when removing one of the charges, this object change into charged object. Let's say that we have an object which is already neutral. By removing negative charge from this object, the only remained one will be positive. So we call it positive charge or hole as a result of removing electron or negative charge. Like guys repel each other and unlike attract each other. So if we have positive charge with positive charge, they are going to repel each other. If we have negative charge and negative charge, they are also going to repel each other. But if we have positive charge with negative charge, that means they are going to attract each other. Conductors and insulators, guys. What's the difference between them? Conductors are substances which are able to transfer the charge, as they already have an extra charge and they are able to transfer the charge. Insulators are substances which are unable to transfer the charge. So, insulators are materials through which a charge will not move easily, while conductors are materials that allows charge to move about easily. Good conductors like copper, aluminum, plasma, graphite, water. Bad conductors like glass, dry wood, most plastics, clothes, and dry air. What type of a charge does an electron carry? It's a negative. Well done. In a conductor, which particle move freely to conduct electricity? Well done, electrons. A positively charged object is placed near negatively charged object. What will occur? Attraction. Well done. What is main property of a conductor? It allows the free movement of charges. Well done. What is the electroscope, guys? Electroscope is a set that we can use it to measure the amount of electric charge in an object. It consists of a knob and leaves. The knob is the one which we approach the charged object towards it, and the leaves are the parts which are going to move away from each other or towards each other to measure the type and the amount of charge exists in this object. Here is the electroscope, guys. We have a rod. This rod is charged by negative charge. And as we said before, any object which is not charged, so it's a neutral. That means this object carries both positive and negative charge. By approaching the rod towards the knob, there will be a repulsion between negative charge and negative charge, and the negative charge going to push towards the leaves, as you saw, guys. So the two leaves will carry the same charge, and as a result of that, they're going to repel each other. By moving the rod away, the charge is going to move, returning back to their place, original place. So the two leaves will return back neutral and going to move towards each other. Here, a hand which is also neutral, there is no change occurred or happened. By the same way, if I approached the positive rod, so the negative charge will be attracted and collected at the knob towards the positive rod. So the two leaves downward will carry a positive charge, so they will repel away from each other. So guys, as we define the electroscope, it consists of metal knob connected by metal stem, two thin, lightweight pieces of metal foil called leaves, and these leaves are used to measure the amount of charge in an object by moving away from each other or close to each other. Ways to charge a neutral object. We have two ways to charge a neutral object, guys. By something called conduction or by induction. Conduction occurs by touching each other. When a charged object touches a neutral object, so the charge is going to move from the charged one to the neutral one. So we will say that this object is charged by conduction. But if we did like the last simulation, just by approaching the knob from the knob without touching it, like this. Before approaching the knob, the object, the electroscope, was neutral. After approaching the rod, we are going to notice that the charge will be collected in a certain place. Instead of being equal amounts of charge, positive and negative, at the knob, a negative charge is going to move from the rod or from the leaves to the knob itself. So the leaves and the knob will carry more charge and will be charged. As you can see, guys, this one is a method of a charging object, but without conduction, it's with induction, guys, called with induction. Charging with induction. Coulomb's law. Coulomb's law, guys, is a law which describes the electric force between two objects. Similar charged objects can repel each other, or oppositely charged objects can attract each other. So there's a force of repulsion or attraction occurs between objects. How to measure this force? Let's say that if we have two charges, charge A and charge B, let's say both of them are negative charge, so they are going to repel each other. As the distance between them increase, the repulsion force decrease. They are unable to repel each other. As this distance between them decrease, there will be more able to repel each other. So, as the distance increase, the force decrease, or as the distance decrease, the force increase. So the relation between force and distance is an inverse relation. Most of the relation with distance is with the square of the distance itself. So the force is inversely proportional with the square of the distance, guys. And also the amount of the charge, the value of the charge. If here -5 and here -5, the attraction force will be weaker than if this charge is -10 and this one is -10. So F is directly proportional with the value of the first charge, and also F is directly proportional with the value of the second charge. So we can write the relation as these guys. F is directly proportional to Q1 multiplied by Q2 divided by R squared. To remove the relation sign, we can put a constant. So the rule will be F is equal to K, which is constant, column constant, Q1, Q2 over R squared. So Coulomb's law, the magnitude of the force between 2 points charges, QA and QB, and at distance R apart can be written as follows. F equal K QA QB over R squared, where K is Coulomb constant and is equal to 9 times 10 to the power 9 Newton meter squared by Coulomb squared. If you are unable to memorize the unit of K, you can conclude that F is measured in Newton, Q is measured in Coulomb, any charge, guys, measured in Coulomb. So we have 2 Coulomb, it will be Coulomb squared. That's measured in meter, so it will be meter squared as R squared. So the unit of K will be Newton meter squared per Coulomb squared. K equal to F R squared over Q A QB. So it will be F in Newton times meter squared over Coulomb squared. 1 Coulomb, guys, is the charge of 6.24 times 10 to the power 18 electron. So 1 Coulomb is equal to the charge of this value. And each electron has a charge of -1.6 times 10 to the power -18 Coulomb. So guys, 1 Coulomb is equal to the charge 6.24 times 10 to the power 18 electron or proton. So 1 electron is equal to 1 over this number, the charge of 1 electron, 1 over this number in Coulomb, which will be -1.6 times 10 to the power -19 Coulomb. What does Coulomb's law primarily describe? The electric force between charged particles. When a negative charged rod touches a neutral electroscope, the electroscope becomes negatively charged. Well done. What is the value of elementary charge? Elementary charge, that's mean 1 electron. It's the smallest charge, guys. 1 electron or 1 proton. So it will be 1.6 times 10 to the power -19 Coulomb. 2 charges, QA 3, QA equals 3 microcoulomb. So we have to transfer it into coulomb, so it will be times 10 to the power -6. And another one, QB, Coulomb of course, QB will equal to -5 times 10 to the power -6 also, Coulomb. The distance between them is 0.2, or is 0.2 meter. He asks for F, and the value of K is provided. Before solving this problem, guys, you have to know that negative is removed, not calculated, because you are finding the value of force, and negative here just represents the type of the charge, not its magnitude. So the answer will be F equal to K 9 times 10 to the power 9 multiplied by 3 times 10 to the power negative 6 multiplied by 3 times 10 to the power negative 6 divided by 0.2. This one is 5, not 3. So it will be 3 times 5 times 9 over 2. And let's simplify these exponents. 9 and negative 12 will be 10 of power negative 3. 0.2, that's mean times 10. So it will be times 10 of power negative 2. So 9 times 5, 45 times 3, 135 divided by 2 will be 67.5 times 10 of power negative 1. So the answer, I think, will be this one. What is the meaning of field, guys? Field means area. When I say electric field, that means the area of electric charge. So we can define the electric field as the area which is surrounding the electric charge. An electric field is a property of the space around a charged object that exerts force on other charged objects. Measuring the electric field requires a small positive charge called a test charge Q dash. So, as we said, the electric field is the area surrounding the electric charge, and the property of the electric charge appears through it. To measure the electric field of a certain charge, you need something that can't affect the field of the charge itself. I have a charge called Q. I need to measure the electric field of this charge. If I approach from it a neutral charge, there is no force will occur. There is no attraction force or repulsion force, as the neutral one will not affect the charge itself. If I approach a charged object with a large value or a large charge, it will be attracted or repelled from that main charge which I'm trying to measure its value or its electric field or its properties, but it's going to affect the field itself, as long as this charge has also an electric field. So, to measure electric field of a certain charge, you need something called a test charge, which is a small charge called Q dash. This is a charge with neglected electric field or electric force. So the only force which is applied here is applied by the main charge Q. So a test charge should be small enough so that its effect on the charge you are testing Q is negligible. According to Coulomb's law, the force directly proportional to the strength of the test charge Q dash, so the ratio of the force to that strength will be like this. E is equal to F over Q dash. E is the ratio applied, is the ratio of the force applied by the main charge to the small charge. Or we can write the rule in another form of Coulomb's law. As Q is very small, so its charge is neglected. So the rule will be only depends on the main value of the measured charge. So E will be equal to KQ over R square. So we have two rules to find the electric field. The first one, which is depending on Q, the main charge itself, and you use this rule in the case of F, the force is massed, or the rule which is using the force, the electric force of the main charge divided by the value or the charge of the test charge. Who can, guys, tell me what is the measuring unit of E? Well done. Force measured in Newton and Q measured in Coulomb. So E, which represents the electric field, is measured in Newton per Coulomb. To represent the electric field, guys, we represent it using lines. These lines coming from the charge or moving towards the charge are straight lines. Moving towards the charge or coming from the charge. So we have two types according to two types of charges. The one which you produce the lines and the lines are moving away from the charge is positive. The one which is the lines moving towards the charge is negative. So electric field lines, guys, indicate the direction of the force due to the electric field on a positive touch charge. So when scientists decide to find this charge or the direction of this field, they used a positive test charge. And using this positive test charge, they were able to find the direction of the field. So if we have, as we said, if we have a positive charge and positive test charge, they're going to repel each other, and the force applied by the main charge, which is positive, will push the test charge away from it. So the direction of the electric field is away from the positive charge. While if we have a negative charge and test charge, which is positive, so it will be attracted to and move towards the negative charge. So the direction of the field will be towards the negative charge. The direction of the electric field at any point is the tangent drawn to a field line at that point. The spacing between the lines indicates the electric field strength. As the amount of the lines increase and the space between them decrease, that means the field is more stronger. The electric field lines are directed towards negative charge, as we said, and away from positive charges. Here is the positive charge and here is the negative charge. Attraction and repulsion, guys. Notice that if we have two similar charges, the electric field lines are unable to flow from one charge to another. So they are going to bend at the middle. This wave bending makes them repel each other. But here, the lines are able to flow from one charge to another charge. Here, positive charge has a strength or field less than the negative one, as the amount of arrows of the positive, which represents the field, is less than the amount of arrows which represents the negative. So the field of the positive smaller than the field of the negative. But anyhow, the arrow is going to flow from the positive to the negative. And also here, the arrow is going to flow from the positive to the negative with different fields. Here's a positive charge, guys. The arrows which are present the electric field are moving away from the positive charge. By putting another positive charge, we will find that the electric field going to bend and move away from the charge by moving in close. The charge or the electric field lines going to move up and down. But by changing the charge into negative, the arrows will be able to flow from positive to negative, from positive charge to negative charge. Van de Graaff generator, guys. Van de Graaff generator is a set which, depending on a belt, this belt is rotating on two balls to make a friction with the balls, collecting negative charge and making the electrostatic charge collected on the metal dome or metal ball. What happens to the electric force between two charges if the distance between them doubled? Distance doubled, so it will decrease to 4 times. Quarter, it's a value. So it becomes 4 times weaker, guys. A positive charge is placed in an electric field. What will be the direction of the force acting on it? Along the direction of the electric field. If the electric field is assigned towards the charge, which is negative, so the force will be assigned towards the charge. So the force has the same direction of electric field. 2 microcoulomb, guys, charge is placed in an electric field of 3 times 10 to the power 5 Newton per coulomb. What is the magnitude of the force acting on this one? So we have Q dash, small charge, point charge, E, electric field. 2 microcoulomb charge is placed in an electric field and 3 times 10 to the power 5 Newton per coulomb, so it's electric field. What is the magnitude of the force? E equal F over Q. So F is equal E. F is equal EQ. So 2 times 10 to the power negative 6 multiplied by 3 times 10 to the power 5. So it will be 6 times 10 to the power negative 1. It will be 0.6, guys. So as we said, guys, the answer is 0.6 Newton. Application of electric field, guys. We have different applications of electric field. The first one is finding the electric potential difference, which is the work done to transfer a certain charge between two terminals of a conductor. Which often is called potential difference, is the work needed to move a positive test charge from one point to another point, divided by the magnitude of the test charge itself. So the work done to move this charge divided by the value of the charge is called the electric potential difference. Work is measured in joule and charge is measured in coulombs, so the potential difference will be joule per coulomb, or we are going to know later volt. Equipotential, guys, when the electric potential difference between two or more positions is zero. There is no difference in concentration of electric charge. So there is no movement of the charge itself from one place to another place. Millikan experiment, guys. Millikan experiment is an experiment used to measure the value of electric field as a result of the weight of the drop of oil. as the weight of the drop of oil increase, we need more electric field, making it suspended in its place between two charged plates. Here is the experiment, guys. This point represents an oil drop, and this point or this oil drop is moving under the force of gravity downward. By increasing the voltage, so the force of the electric field will be applied against its weight or the attraction force of gravity. So, by applying more electric field, you will overcome the gravity and make it move downward. I will decrease the voltage, trying to make it just equal to the weight of the oil drop mg, and I will run it. So as you notice, guys, mg now is a little bit greater than the electric field, so I will increase the electric field a little bit. Similar. So if they are similar, the oil drop will not move. At this point, EQ equal mg. EQ is the force of the electric field. mg is the force of the gravitational. F electric is equal to F gravity. So QE is equal to mg. By this way, you are able to know the value of electric field by knowing the charge of the oil drop and its mass. The third application, guys, is capacitor. Capacitor is a device for storing electric energy just for a while. After that, it's able to discharge this electric energy again. So capacitor, guys, is a device for storing electrical energy. If you connect 1 volt power supply across a capacitor, the potential difference between the two plates of capacitor would be 1 volt. Till the electric current or the potential difference which is connected removed, the capacitor will be able to discharge this 1 volt power again. So the capacitor is amount of charge stored in it divided by the potential difference between its plates. And we are going to study the capacitor later, guys. What is the relation between electric force and the magnitude of electric charge involved? Directly proportional to the product of their charges. The electric field between two charges is strongest where the charges are equal in magnitude. If the electric field at a point is 0, what can be concluded about the forces acting on a charge at this point? Forces are balanced. Moving to a new part of our lesson, guys, which is called electricity and electric current. Who can tell me what is the meaning of electric current and what is the difference between the charges in electric current and electrostatic charges? Electric current is a flow of charged particles. So here in the electric current, the current consists of flow of electric charge. So the electric charge are not stationary anymore. They can move from one place to another place according to the difference in concentration between 2 points. The charge is going to leave the place or the point with high concentration, moving to the point of low concentration. We have 2 types of electric current, guys. One of them is real current, and the second one is the traditional or conventional current. What is the difference between them? The real current is the movement of electrons itself from the negative pole to the positive one. So, here is the circuit, and here is a battery. The symbol of the battery consists of 2 lines. One of them is long line and the other one is short one. So this symbol represents a battery. The long one is positive, as positive consists of two lines, so it's long, and the short one is negative. The real current is the movement of electrons from the negative pole of the battery to the positive one in this direction. So it's the real current. Before discovering electrons, scientists were unable to find the real current. So they presented the current by a direction from positive to negative. So they presented the current by the movement of holes. Holes are the places of removed electrons. So the electron is going to move from negative to positive through the circuit, while the holes moving from positive to the negative through the circuit. This one, the movement of electrons, is the real current, while the movement of holes is the conventional or observed current. So, real current is the direction in which a negative electron moves, while conventional current is the direction in which a positive test charge moves. Here is the direction of conventional current from positive to negative through the circuit, and here is the movement of real current, which is called electron flow from negative to positive. What is the meaning of electric circuit, guys? Electric circuit is a closed path for electrons. So the electron can flow from the beginning or a certain point through the circuit, returning back to this point. We have two expressions, guys. One of them saying that the closed circuit, and other one is open circuit. Closed circuit, that's mean all parts of the circuit are connected to each other. So the path is provided for electron to move from one place to another place, to move from the battery, returning back to other side of battery. While the open circuit is the circuit which is open, that's mean the path of electron is not provided. So there is no current flow through the circuit. There is no current flow through the circuit. Electric circuit is any closed loop or conducting path, allowing electric charges to flow. The electric current flows as a result of a difference in concentration of electric charges, which is called potential difference. We have three properties, guys, that describe the movement of electrons through the circuit. Here is the chart which show the flowing of electrons. As you can see, guys, the electrons are moving from the negative pole, which is a small dash above V, moving through a certain component in a circuit. The cylinder is a certain component, maybe bulb, maybe anything, returning back to the long dash of the battery, which is positive. So we can say that we have three different terms to provide the properties of electric current that flows through a circuit: resistance and potential difference and current intensity, which is represented by electron density. Let's say that the electrons are coming from the negative direction, moving to the positive one, as you can see, guys. If I'm going to increase the resistance length, notice what will happen. I'm going to decrease it. The flow of electrons became faster. So as the length of conductor decrease, its resistance also decrease. If I'm going to increase the area, you will find that the resistance will also decrease and the flow of electrons became faster. If I decreased the area, so the flow of electrons will be slower. The potential difference is the work done to transfer the electrons from one point to another point according to the difference in concentration. So if you increase the potential difference, that means you increase the work done, which makes the electron flow faster. So guys, we can say that we have three terms: resistance, potential difference, and current intensity. Resistance is the opposite of a conductor to make the charges flow through it. It depends on the area of conductor and the length of conductor and the material of conductor, of course. For the same material, the length and area of conductor make the resistance of conductor differ. By increasing the area, the resistance decreases. By increasing the length, the resistance increases. Suppose that they are going to pass through a pipe. As the thickness of the pipe increases, it's easier for you to pass through it. If it became narrow, that means you will be unable to pass through it, or it will be difficult to pass through it. Also, as the length of the pipe increases, it will be more difficult to pass through it. As it becomes shorter, that means it's easier to pass through it. V. As we said, V is the potential difference, which means it's the work done to move amount of a charge through two terminals of conductor. As the work increases, the potential difference increases. As the potential difference increases, that means more charges going to flow through the conductor. Work means force pushing electrons will increase, so force that pushing electrons will increase, that means more electrons will flow through the conductor. While I is the amount of charges, which depend on potential difference and resistor. As the resistance increases, the amount of a charge going to flow through the conductor decreases. As the potential difference increases, the amount of charge going to pass through the conductor will increase. So there is a relation between V and IR. V is directly proportional with I. V is directly proportional with R, while I is inversely proportional with R. If the resistance of the conductor increased at a constant I, that means the potential difference must increase also to provide the same amount of a charge that pass through the conductor. If the potential difference increase at constant R, that means a lot of charges going, or more charges going to pass through the conductor. While if V is constant, as the resistance increase, less amount of charge going to pass through the conductor, so that means the current intensity will decrease. So this relation, guys, represents something called Ohm's law. Ohm's law found the relation between the three physical terms that control the movement of electrons through a conductor. And as we said, guys, the amount of resistance is depending on three physical terms. One of them is the length of conductor, L, and the other one is A, the area of conductor, and the third one is the material itself, which is the ability of conductor to transfer the electric current. As the resistivity increases, that means resistivity is opposite to conductivity. Conductivity is sigma, while resistivity is rho. So, as the resistivity increases, less amount of a charge will be able to pass through the conductor. If the length increases, that means R also will increase. If the area increases, R will decrease. So, it shows the relation between three physical terms: resistivity or conductivity, it depends on the given, and length and area. R is equal to rho L over A, or R equal to L over sigma A. What is the difference between them? Only the difference between them is rho, equal 1 over sigma. Rho is the resistivity, while sigma is conductivity. As the conductivity increases, the resistance will decrease. As the resistivity increases, the resistance will also increases. Who can tell me what is the, according to Ohm's law, V equal I times R. R is measured in ohm and have this symbol. I measured in ampere, and V is measured in volt. Look guys, we can say that volt is equal to ampere times ohm. And if we return it back to the definition of volt, potential difference, as we said before, V is the work done to transfer amount of a charge through a conductor. So work is represented by joule per coulomb as the charge measured in coulomb. While the current intensity can be measured in another unit different from ampere. Like what? Let's say that I is equal to V over R, which is mean volt per ohm. Or I is the amount of charges that pass through a conductor in 1 second. So we can say that coulomb per second. While the only measuring unit for resistance is ohm or volt per ampere. So, who can tell me what is the measuring unit of resistivity? R is equal to rho L over A. So, the resistivity is equal to R A over L. R measured in ohm, while area measured by meter squared, and L by meter, so meter with a square, so ohm per meter. So we can define the resistivity as its resistance of a conductor by unit length. So as we said guys, the properties of electric current. Potential difference is the work done to transfer amount of charges between two terminals of conductor, V equal work done over Q. Current intensity is the amount of a charge that flows between two terminals of a conductor through 1 second, I equal Q over T. Resistance, it is the opposite of a conductor to flow of electric charge, R equal V over I. Ohm's law, V equal I times R, and we described that and explain it. Here is a conductor, guys, and we can see the relation between V, I, and R. As V increases, I increases. As V decreases, I decreases. As R increases, I will decrease. As R decreases, I will increase, even though V is constant. So we represented the Ohm's law. Here are, guys, some symbols. We can find them in a circuit, in a drawn circuit. A straight line represents a conductor, while this port represents a switch, fuse, capacitor, two parallel lines equal to each other. If they are not equal, there will be a cell of battery. What is the difference between cell, guys, and battery? Cell is only one battery, one unit, like this. The battery is a group of cells. A group of cells. This one represents the ground, lamp, voltmeter, ammeter, DC generator, inductor, potentiometer, resistor. Let's explain all of these terms. Resistor, fixed, that means a resistance, a component inserted in the circuit, which has only one value. You can't change it. You have to replace this component if you just like to change the value of total resistance. Potentiometer is a variable resistance. That means you can change the value of the resistance without changing the component, like exactly the volume button in your phone or even in your music player. Inductor, it's a coil that makes something called a magnetic field, and we are going to study it next lesson. A ground, it's a wire which you connected to the ground to discharge the extra electrostatic charges, to get rid of it, because it can or may damage your set. Lamp, it's a lamp. DC generators, that mean generate electric current. DC is a type of current called direct current, while AC is a type of current called alternating current. What's the difference between them? DC is direct current, which is mean the current flows in one direction, while AC is a current which can flow in both directions, which is mean the direct current has positive and negative poles, has a polarity. AC doesn't have. Direct current is like a battery. When you connected the battery inside a circuit, or even when you installed it inside your TV remote to use it, you have to figure which pole is positive and which one is negative. While the AC is like your wall plug. As you plug any set inside the wall plug, you can't distinguish which one is positive and which one is negative. It has something called no polarity, because the current is alternating. The difference between the direct current and the alternating current: direct current cannot be transferred for long distance. By time, the intensity decreases as the length of the conductor increases, while alternating current can be transferred for long distance with high volt as we know, guys, we use in our homes 220 volt electric current. But in our sets, we just use 3 volts, 9 volts, 12 volts, depends on the set itself. As the alternating current can handle high voltage with low ampere for a long distance, while direct current can handle high ampere with low voltage. So AC is suitable for transferring it from the power station to our homes, while direct current is not suitable for that. What is the difference between voltmeter and ammeter? Voltmeter is a set which is connected in a way to measure the potential difference of a certain component in a circuit. Ammeter is a set which is connected in series connection to measure the concentration of electric current, which is mean the current intensity. We have two methods of connection, guys. One of them is called series connection, and the other one is called parallel connection. What is the difference between them? Let's figure it out on batteries. Then resistors. Then we will know how to connect voltmeter and ammeter. Series connection. Series, that means the components follow each other. Which is mean, if I'm talking about battery, now I'm talking about battery. So I have one cell, this one is positive and this side is negative. So I'm going to connect another one and another one in the shape of series following each other and inserting them to the circuit. The aim of a series connection of battery is increasing the voltage as V equals the summation of V1 plus V2 plus V3, while the current intensity is constant, which is the current of the lowest one of them. While parallel connection aims to increase the current intensity while keeping the voltage the same. Here is the connection of parallel connection. I connected all the positive poles together. I connected all the negative poles together, then inserted them to the circuit. In this connection, this type of connection, I total is equal to the summation of I's, which are I of each battery or each cell, while V is the greatest one. If they are equal to each other, so one of them. If they are different, 3 volt, 2 volt, 1 volt, so I'm going to take only the greatest one. So we explain now the difference between series connection and parallel connection. Series connection in battery, that means the negative pole of one cell going to be connected with the positive one, the next positive, and then negative, positive. So it will be positive, negative, and so on. This type of connection aims to increasing the voltage with keeping I constant. Here in parallel connection, I'm going to connect all of positive poles together and all of negative poles together, then inserting them inside the circuit itself. This type of connection aims to increasing the current intensity with keeping the voltage for the greatest value of any cell. So I in parallel connection is the summation of i's, while V is the greatest value. We have another type of connections for resistors. Here is the sign of resistor, a zigzag line. So if we connected these resistors together, that will mean R1 is connected with R2, is connected to R3, following each other. So it's a series connection. This type of connection aims to increase the resistance by R total is equal to R1 plus R2 plus R. So the total resistor of this connection, which is series, is equal to the summation of all resistance or resistors that are connected inside this connection. While parallel connection, as we said, we are going to connect each sides together, then insert them to the circuit. So parallel connection will be, here is resistor 1 and the two terminals of resistor 1. Here is resistor 2 and here is resistor 3. I'm going to connect all of them together, then inserting them to the circuit. So R1, R2, R3, the right side of all resistors are connected together, and the left side of all resistors are connected together, then inserted to the circuit. The aim of this connection is decreasing the resistance, as 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So by the end, you're going to find that R total is smaller than the smallest resistor inserted in the circuit. The connection of voltmeter and ammeter. What is the voltmeter and ammeter firstly? Voltmeter is the set which measures the potential difference between 2 points. So here is a component which is a resistor, and I would like to measure the potential difference between its 2 terminals. So I need to measure the potential difference. That means I need to measure the difference in concentration between these 2 points. So I'm going to connect the voltmeter in parallel because I aim to measure the difference in concentration between these 2 certain points. So the voltmeter is connected in parallel, while ammeter is connected in series, as I need to measure, using the ammeter, I need to measure the amount of a charge that flows through a certain branch or part of a circuit. So I would like to measure the current or the amount of charge that flows through this part. So I have to connect it through series connection. If I connected the ammeter in parallel connection, which means the amount of charges which flows through the circuit going to be branched, and some of it move in this direction and other move in this direction, which mean the ammeter will not measure all of the charges that flow through the circuit, which is not correct and will provide a wrong reading. So ammeter is connected in series. Ammeter and voltmeter, guys, are 2 sets which are developed or modified from a certain set called galvanometer. What is the galvanometer? Galvanometer is a small set that measures small currents. To measure the small currents, you use very sensitive set, which is called galvanometer. It just only measures the current. This galvanometer can be changed into ammeter or voltmeter. Let's know how to change a galvanometer into voltmeter or ammeter. Here inside the circuit, I require all of current to pass through this resistor. As if I have amount of a charge of 100 charge, for an example, flow through the circuit, and we reach this point, that means this amount of charge going to divide into two branches, some of them moving through this wire to the voltmeter, and other move through the resistor. The main aim is to measure the difference in concentration between this point and this point. If we allowed a lot amount of charges to pass through voltmeter, that means you will have a wrong reading, you have a mistake in your reading, and your reading will not be accurate. So we just connect with the galvanometer, a resistor. This resistor has a high value, and we connect it in series to prevent the electric current from flowing through this branch and keep moving forward through the main resistor or through the main part of the circuit. So changing galvanometer into voltmeter happens and occurs by connecting a large value resistor in series with the galvanometer to change it into voltmeter. But here you need to measure the amount of current that flows through the conductor. To measure it, you will connect with a galvanometer a small resistor, very small resistor, in parallel. So here is the galvanometer and here is the resistor. The electric current going to move from here, passing by the small resistor with the highest value, and only small part going to pass through the galvanometer. By finding the percentage of the amount of charge that flows through the galvanometer, you will find the total amount of charge that flows through the conductor. So changing galvanometer into ammeter is by connecting a very small value resistor in parallel with the galvanometer. Here is the connection. Here is the parallel circuit. All positive are connected together. All negative are connected together. Then they are inserted or immersed inside the circuit itself. In series connection, positive of one cell is connected to negative of the next cell. Positive is connected to the negative. Then they are inserted inside the circuit. Here is series connection, and here is parallel connection. Here is the connection of resistors. As we said, guys, and notice that 1 over R total is equal to 1 over R1 plus 1 over R2 and so on. So the total resistance found in parallel connection is less than one of them, the lowest one. Here R is the summation of resistors, similar to the voltage. So the voltage and the resistor are measured in the same way in series connection. I'm going to add them. While V is constant through parallel connection, and R, which is the resistance, decreases through parallel connection. What happens to the total resistance in a circuit when two resistors are connected in series? Series, so it increases. Two resistors, R1 equal 4 ohm, R2 equal 6 ohm, are connected in parallel. What is the total resistance? So we said 1 over R total is equal to 1 over R1 plus 1 over R2. So 1 over R total is equal to 1 over R1, which is 4 ohm, plus 1 over R2, which is 6 ohm. So that's mean 24. 1 over R total is equal to 24, and here 6 plus 4. So 1 over R total will be 10 over 24. So our total reciprocal of both of them, so our total will be 24 over 10, which is 2.4. What is the SI unit of electromotive force? Electromotive force is the voltage of a battery, so volt. Which of the following statements about current intensity is not correct? Read it well. So the answer will be it increases with increasing resistance. Well done. If the voltage across a 10 ohm of resistor is 20 volt, what is the current flowing through it? So V equal I, R, V equal R. So I equal V over R. So 20 over 10 will be 2 ampere. The electric power, guys. What is the electric power? Electric power is the ability, as we said before, ability to do work at a certain time. The work done for a certain time is called power. So power is defined as the rate of which electric current energy transferred or converted into another form of energy, such as heat, light, or mechanical energy in an electric circuit. We said P is equal to work done over time. And work is equal to V times Q. From this rule, V is equal work over Q. So the work is equal V times Q. So the power is equal to V times Q over time. This part represents current intensity, so we can say that V times I is equal to the power. And also we can say that V equal I times R. So I square R also equal power. And we can replace I by V over R. So V multiplied by V over R will be power, which is V squared over R will be the power. So the power can be found by different rules. VI, I square R, or V square over R. Any one of them. The measuring units of power are watt, voltmeter times ampere, volt times V times I, ampere square times ohm, I square R, volt square over ohm, V square over R. Types of conducting materials, guys. We have 3 types of conducting materials. Bad conductor, insulators, good conductors, and superconductors. Bad conductors are materials with high resistance, which doesn't allow electric current to flow through it. Good conductors are materials which allow most of electric charges to travel through it. Superconductors are materials that allow all of the electric current to pass through and have zero resistance. Kirchhoff's law, guys. Kirchhoff's law are found to find the relation between different branches and different parts of the circuit. First law of Kirchhoff saying that if we have a knob or a joint in a circuit, like this part here, I'm going to draw a circuit here, Here is the current, and here is the battery. The current is flowing from negative. Electrons are moving like this. It's going to be separated, then collected again. At this point, to return the same. Let's move with the arrows. If we consider that 10 amperes are produced from the circuit, all of the numbers here for explaining. There is no base for the numbers I'm saying it. So 10 amperes will flow through the circuit to reach this joint. At this joint, the 10 ampere will be divided into two parts according to the resistor of each part. The high resistance takes low ampere and the low resistance takes high ampere. Let's say that here 2 amperes going to flow and here 8 amperes going to flow. Moving again to reach this point. At this point, that 8 ampere and 2 ampere going to join each other again to present the 10 amperes. Let's study each point and each joint separately. Here we have 3 branches. 1, 2, 3. 2 of them is coming out from the joint and only 1 is moving in the joint. If we said that 10 amperes are entering the joint, 10 amperes are entering the joint. So the branch number 1 carrying a current of 10 ampere and 2 ampere, 8 ampere moving out of the joint, which are carrying the same current. So we can say that the summation of In is equal to the summation of I out, which is Kirchhoff's first law. Here also 2 ampere are entering the joint, 8 ampere are entering the joint, and by the end 10 ampere are left the joint. So it applies the same rule, which total current which entering the joint is equal to the total current coming out of the joint. Kirchhoff's first rule, junction rule, at any junction or not in an electric circuit, the total current entering the junction is equal to the total current leaving the junction. This is based on conservation of current or charges. Mathematically, summation of In equal to summation of I out. Moving to Kirchhoff's second law, he said that the summation of voltage across any parts of the circuit is equal to 0. In closed loop is equal to 0, which is mean I times R, the summation of I times R is equal to 0. So, in any closed loop of a circuit, the sum of potential difference across the elements is equal to 0. This is based on conservation of energy. This includes the voltage drop across resistors and the EMF source in the loop. Let's say that we can write Kirchhoff's second law by this way. V is equal to summation of I R. So V minus summation of I R equal to 0. Here is the Kirchhoff second law. If we said that the voltage is 12 is equal to the current is moving through this loop is 2 ampere. I found it as The total resistance is 1 plus 2 plus 3. So the total resistance is 6. As the resistance is 6 and the voltage is 12, so the current will be 2 ampere. I equal V over R. 12 over 6 will be 2 ampere. So the current that flows through the circuit is 2 ampere. So 12 is equal to 2 times 1, but added to 4, 2 times 2, and added to 6, which is 2 times 3. So 12 equal to 2 plus 4 plus 6. If I added all of this voltage, so 0 will be equal to negative 12 plus 2 plus 4 plus 6. So the summation of all voltage will equal to 0. Here is the Kirchhoff second law, and we will going to solve a lot of questions on this part. Here is the connection of ammeter and voltmeter. The resistor which is connected to a galvanometer to change it into ammeter is low resistance and connected in parallel and called shunt resistance while the resistance which is connected to galvanometer to change it into voltmeter is called multiplier resistance. Here is the rule of finding the shunt resistance is the electric current which passes through galvanometer divided by total current minus the electric current passes through the galvanometer multiplied by Rg, and the one which is used, the rule which is used to find the multiplier resistance is V over Ig minus Rg. Which of the following is a good conducting material? Horse copper. What is the SI unit of electric power? Watt. Which of the following formula is correct for calculating electric power? P equal VI. Kirchhoff's first law is based on conservation of charges. Well done. In Kirchhoff's first law, the summation of IN equals summation of I out. What does this rule apply to? A junction in a circuit. By the end, guys, we reached the end of our session. Study well. Prepare your questions for the live session. And see you, inshallah.